Hello, everyone. I am Cristian Klein, Senior Cloud Architect with Elastisys. I will be your host for our first fireside chat around cloud-native security. With me in our virtual studio is Anders Eknert, Developer Advocate with Styra, and Steve Giguere, Cloud-Native Security Advocate with StackRox, which has recently been acquired by Red Hat. Warm welcome to both of you. Let me start with some house rules. We want to make this cozy and interactive. So if you, the audience, have any questions, don't hesitate to ask in the Q&A or raise your hand using the corresponding Zoom buttons. Also, this session will be recorded. So if you miss something or need to drop out, no worries, you can rewatch everything later. Now let's dive in. Anders, tell us a bit about yourself.
Sure. So I'm Anders. I work as a developer advocate for Styra. And Styra is the company and also the inventors behind Open Policy Agent. And yeah, for my own account, I come from a pretty long background in software. And for the last 6 or 7 years, I've mainly been involved in identity systems of various kinds and sorts, and that's how I got into policy and policy management.
Thank you, Anders. Steve, can you tell us a bit about yourself?
Yeah, sure. So I'm probably similar. I started off writing code way back, so far back I'm not even going to tell you. But from there, I moved into a lot of took an interest originally in code quality, and then moved from there. It kind of made a natural progression into security. So from there, I started working with a company called Synopsys. I don't mind mentioning them, where we had SaaS tools, IS tools, software composition analysis, basically the whole kind of deal around more monolithic security. And then taking a very keen interest in containers and Kubernetes, I started working with a company called Aqua Security, and then from there into StackRox. StackRox, I obviously a fan of what they do. They're a Kubernetes native security solution, and so that's where I am now. And I'm as you mentioned, a cloud native security advocate, talking about how to secure the cloud. So I'm happy to be here. Thanks.
Thank you for joining us. So since Anders started, let me now ask Steve the first question. Since you mentioned that you moved into cloud native security, what, in your experience, are the biggest security headaches when moving from legacy stacks to cloud native?
You're supposed to start with an easy one. So off the top of my head, I would say lift and shift. The notion that moving to cloud is as simple as getting a cloud provider, taking what you did, putting it in a container, and then pushing it up. Because to do that, you're kind of not really gaining any of the benefits that you get. Well, you are getting some, but certainly not the security benefits. I wouldn't say that you get from doing that, right? You're not benefiting from re-architecting. And I think some people rush that progress because of the water cooler pressure around being cloud native. So that's my short answer. And now I'm curious what, I assume we're going to hand it over to Anders because I want to hear what he says. And then I'll see if I will play off that. Before
handing over to Anders, I just wanted to say it's not that I asked this difficult question. We collected from the audience a few pre-questions, and this is one of the biggest concerns that came from them. Anders, would you like to say? Yes. Anders, would you like to say what is, in your experience, the biggest security headache when moving from legacy stacks to cloud native?
Yeah, sure. I think the security headache is pretty much the same as the any other headache around that kind of microservice or cloud native stack. And I think primarily it's about diversity, like moving from one or maybe two application platforms or like an application server, and you had like your Java app, and it was kind of simple in that way. And at most you'd have maybe one database, or like two if you were really like wild and crazy. And now you have all these disparate systems interacting with each other, and often, like in many organizations, applications that span not only like technical environments but also across so many different teams. So you have to kind of interact with like the politics of any organization in order to kind of work with the system as a whole. And of course, that poses a big challenge in terms of security as well, because how do we know, like, how can I keep track of all these components in the stack? Like, I can obviously know what I am doing, but how do we kind of keep track of the whole? I think that's a major challenge in the cloud native stack for security, but for it's just a challenge in general.
Do I understand correctly? Basically, you're saying that there's a larger number of moving parts, and that makes it a bit more difficult to secure the system as a whole.
Yeah.
I think can I add to what Anders said?
Of course.
Yes, please go ahead.
Cool. All right. Awesome. Yeah, because that was really that plays off the opposite of the next step from what I said. So if you didn't rush with the lift and shift, and then you moved into a microservice architecture, and I think where we're going is that a monolith would have been all Java. Whereas a microservice means you're going to move into new languages, and that correct me, Anders, if I'm wrong, but that's where your technology stack diversity means your security solution needs to be diverse. And that is totally confusing from a security perspective. Did I summarize correct?
Yep.
Yeah, cool. Yeah, definitely. That's huge. We could go all day on the biggest security headaches. We could just stay on this one question if you want.
Yeah, no, let's move on to a different question.
Okay.
But I think this is also great that we're having both of you, because you have two different perspectives you're kind of providers of two different pieces of cloud security. So then we're having a question right now from the audience. Let's start with you, Steve. What is cloud native security to begin with? What do you understand if somebody tells you, like, oh, you need to invest in cloud native security? What would you understand in that case? What would you recommend?
Who asked that? All right. I actually know who asked that. All right, I'll get him later. So cloud native anything to means to leverage the new environment, leveraging the advantages of the new, I don't know, I just said paradigm. I'm going to stick with it. I'm going to own it. Because if you're moving into cloud, then you start to approach the world of more ephemeral objects. And because of that, and microservice architecture, so reduced code, the size of reduced code, I don't know what you call it, footprints within different services, Kubernetes, the declarative architectures, all of these things around cloud native mean we can change the way we do security to our advantage. So I think that is when we're talking about cloud native security, that to me is what we mean.
Anders, what's cloud native security to you?
Yeah, no, I don't really think I have a crystal clear definition of like cloud native security versus any other kind of security. But yeah, I think what Steve said there, the kind of ephemeral nature of cloud native technologies is certainly a big part of that. Like any pod or containers coming and going, and you don't really have that kind of continuity that you would be used to in a, or maybe like a more like a monolith architecture where people will boast like about their uptime. Like I had an uptime of 2 years, and now we're coming to an environment where like uptime is more like it's something bad. Like you'd expect something to be if something has been running for too long, it's like, wow, that sounds like that's like an anti-pattern. So yeah, that's certainly that to me is central to the cloud native concept, and of course that has an effect on how we kind of work with security as well.
So I would say that basically transition from pets to cattles is what to you is a large component in what cloud native security is about.
Yeah, sure. And of course containerization and all these kind of layers on in which we deploy our software also has meaning in terms of security. Like kind of what 10 years ago or 20 years ago, like if you could kind of escalate your local account privileges to root, that would be like you owned that machine and you could probably like take over the network. today, like in all honesty, that's probably not going to be a big deal if somebody can get root in a containerized environment running in Kubernetes with like proper security measures in place. So there's so many more layers and so many more kind of lines in the defense.
Mm. And we're getting an interesting question from the audience. Do you distinguish between cloud native security and cloud security in general? Or is this kind of like the same thing? Or is one including another? Or there are separate things with a bit of intersection? How would you relate these two, cloud native security versus cloud security?
I'm going to let Anders go first.
Yeah, no, I think for me, it's kind of this idea about defense in depth, where you have where there's just so many layers in a containerized and like kind of cloud native application that a breach in one of these layers, if everything is kind of properly isolated, I think that would be my like this kind of idea of cattle or pets. It certainly applies to security as well.
Mm. And Steve, to you, is there any difference between cloud native security and cloud security in general?
I think there might be a perceived difference because when people think of cloud native security, they tend to side towards the application. And when people think cloud, they're thinking more about the ops or the provisioning. So I don't know that that's true or whether that really makes sense. But if you think of Gartner's terminology like CSPM, Cloud Security Posture Management, now we're talking about making sure the provisioning is correct and maintaining the correct posture of what the cloud is. And yet that doesn't seem to associate at all with ensuring that your microservices are secure. So when people say cloud security, it's like they don't include cloud native security. But when you say cloud native security, well, we are including that part. So maybe cloud native is more of a superset of cloud security. Does that sound fair?
I would certainly agree with you. Feels to me like cloud security touches a little bit upon how do you put your resources in a big cloud provider, whereas sounds to me like cloud native security is also a little bit more about what you put inside those resources. We also got another question. And I'm hoping that I will get different answers from you too. What would be your first security assurance activity you would introduce as part of your software development lifecycle to address cloud native security? Shall we start with you, Steve?
Okay, sure. First security assurance activity. I know who Michael Mann is. He runs the London meetup that I frequent a lot. So he's going to cause us trouble.
Okay.
The first security assurance activity. So there's a lot of things you can do when we're talking about the SDLC or I assume we're talking about CI/CD pipeline in integrated activities, right? And I think if we're moving toward cloud native, we're probably moving toward the statistics of using more open source than not, right? We're not writing our own code. Our own code's probably 20%, tip of the iceberg, and our dependencies are far larger. So I would be looking at something that is closer to either an SCA, so looking at dependencies and open source vulnerabilities that are available, like the low-hanging fruit that both the bad guys can exploit and we can find and provide some sort of mitigation around. That does blur if we're talking about containerization and image scanning, because there is a crossover between what image scanning can do and what a traditional SCA can do. But it would be somewhere in that space to ensure that we're not simply pushing obvious vulnerabilities into our running area. And I think that kind of is like a tie between just making sure we're not misconfiguring something terrible. And that goes back to that sort of cloud security conversation we just had. So but that's not in the pipeline, or not in the traditional application security pipeline. It's in the IAC pipeline. So I don't know if that's what Michael means.
I will have to assume that he means that. Otherwise, he's free to ask another follow-up question. Anders, could you also give your opinion about what would be the first thing that you would introduce, first security activity you introduce as part of cloud native security?
Yeah, I think it would definitely include like segmentation to make sure that every layer of the stack is properly isolated from the other layer. And if there's an application that has no need to talk to a database, it shouldn't be able to. And if there's no need to talk to another application, it shouldn't be able to. So any kind of all these, whenever there's an opening for something, like make sure to kind of plug that unless there's really a need. And if there is a need, it needs to be defined in a, I don't know, everybody loves YAML or whatever, in some kind of declarative fashion. Like if you have dependencies to other services, make sure there's a file that describes that relationship. And if the relationship is not defined, there should be no, there shouldn't be an option to communicate between those two components. So that kind of segmentation, I think, is crucial in the cloud native stack. And I think like one of the challenges when you see like a new CVE is posted, or like, oh, there's this new exploit or breach, or it's often just finding out whether we are affected, like even though we know like for sure we're running this software, but is there any potential chance that somebody from the outside could have access to this directly, because there's so many layers and proper like segmentation and isolation in between.
Interesting. As a kind of a follow-up question to the question we just had, Anders, what would be, let's say, your main categories of security tools that you think are important to have in your cloud native security toolbox?
Yeah, of course. Working for Styra, I'm rather biased.
I almost feel that the audience here asks for shameless plugs, so please go ahead if that's the answer that you would like to provide.
Yeah, of course. Now I'm gonna go ahead and push for that now. But obviously, policy is a big part of this whole cloud native security thinking, and I think like policy is going to be there whether you want it or not. It's not like you can just say like, okay, we're 2 years into this project, let's apply policy. Like you've had policy from the start, whether you have like considered it or not, but the policy is either informal and kind of loosely specified, like a bit here and a bit there. Or you can start to think about policy like kind of like you think of a database, like one central location where you can define who gets to do what and who is not allowed to do what. And I think like without stating the rules, like how can you know whether you had a breach or not, if there's some uncertainty in who was allowed to do something. So yeah, I think that's whether you use OPA or not, that's not like the main point here. But I think like clearly stating the rules, the boundaries of your system, that's going to be imperative.
Yeah, I want to say that you kind of have ID policies anyway, either as tribal knowledge or hopefully in the drawers of the Chief Information Security Officer. OPA takes this approach one step further and basically allows you to codify it so that it's really enforced at every single step and not just staying in the drawer of somebody and then forgetting to enforce it.
Right, and I think it applies to kind of any other layer in the stack as well. Like you can enable code coverage. But unless you actually define some policy on what that means and what should we aim for, what does it matter? Like, is it just gonna, if it's just gonna print out some report in a build system that nobody ever is gonna look at, it doesn't really matter. So I think that's kind of how I consider policy.
Steve, would you also like to take a take on this question? Like, what would be your favorite tools to include in the cloud native security toolbox? Again, your chance, audience requested it, to have your shameless plug.
Oh, I don't have the shameless plug. Yeah, that was I'm going to play off of what Anders said. I think OPA has done an amazing job of providing a standard for security as code, and that is totally backing that. That's an absolute essential. If I'm going to shameless plug, Stackworks does a version of that, but was moving towards OPA, right? So because it predated OPA. So if I were to shamelessly plug what we do, it's the same thing, just a slightly different flavor in terms of saying, this is what Kubernetes can look like. This is what deployments can look like. This is what is good. This is what is not good. And enforcing that in a variety of different ways. That's great. Now, if we take the philosophy of that, which playing off what you said, the elimination of tribal knowledge, if we can work towards anything that does that, then that's a good piece of tooling or automation that we can deploy throughout the pipeline. I think we're quite familiar with things like going way back to static analysis, because those are rules. That's essentially a compiler that looks at code and says you cannot do this. Great, it's declarative. That's what it is, and there are new things there. So I think that's fine to have things like that. So if you look at anything you're doing, and I mentioned SCA earlier, or image scanning, and you ensure that those gates are in place and they're not creating more problems for you, that's actually really important, right? Like a SaaS tool that integrates into an IDE is a good SaaS tool. An SCA that provides pre-prioritized results is a good tool, but one that doesn't isn't. So these are all important for highlighting the different aspects of where things can go wrong in terms of your code, your dependencies, your configuration of your environment, and then translate all of those declarative things into runtime. If you've got those stages worked out, then you're doing small amounts at every phase instead of one big amount of security at only one phase, then we're off to a flying start. And there's a lot of, and just to back it, there's a lot of open source you can use to make that happen, like Opus. So that's where I tend to start with if there's an open source version, do that because it's probably easy, and then move on from there with shameless plugs from us.
Thank you for your answers. As a follow-up to the tooling, so I know that this is something that, let's say, bothers me on a daily basis, and it seems that at least a few people in the audience are also bothered by it. But it has been recently reported that Kubernetes, for example, is a bit struggling between coming up with defaults that give you that wow, it just works effect, versus come up with defaults like, no, it should really make it very hard for you to do anything insecure unless you take an active decision to disable things. So think about, for example, Kubernetes shipping by default with pod security policies that don't allow you to do root. That would be so awesome from a security perspective, but then probably everybody would be just spamming the Kubernetes Slack channel with, why are my containers from GitHub, from Docker Hub not working, and so on. So we have here a few questions in kind of this same area. Like, how can we, where exactly should the security defaults be? Should they be more towards secure by default or more like productive by default? And also, okay, once you change those defaults, how exactly do you decide how far should you go into securing everything, but that would then hamper developer productivity, versus let's first aim for productivity and let's say then we secure things as we decide that the risk is too high. Steve, I know that's quite a long question. I hope that I managed to condense it very nicely. Steve, would you like to give me your take on this?
Holy moly. Okay. Thanks for asking me first. I was so hoping.
Secure defaults.
Secure defaults, yes. That's a complicated question requires a complicated answer. So it can depend on the industry that you're in, what secure by default means, and it can depend on the environment within which you're deploying and the context for that, because I think people can have different defaults for dev versus production, but they might want to warn based on just to let you know that you deviated from those defaults, but nothing has been enforced. So you can demonstrate, if you can do secure defaults right, meaning those who will be subject to those defaults are made aware of them at some point in the life cycle of their application, then I actually like secure defaults. I like the idea of no one ever does this, but having default deny on network policies such that the application comes with the network policies that it needs as part of the application, so that you have the network policy there. So this is going to be talking to these things, and we only talk on these ports. This is the only allowed ingress. That would be amazing. Does that happen? It might prompt that to happen, but it would be good if we took baby steps towards secure defaults, because it's not, I don't know that it's part of our culture yet. So being cognizant of the fact that that's a nirvana from a security perspective, I'm also aware of the fact that we might just prompt developers to find backdoors around our secure defaults in some way or another. So I guess I like what you're saying, but I would love to see us segment the world on our journey from dev to production, so that developers create something in some form of world that means they have awareness of what those security faults are. They learn, they create exceptions with intelligence and data-driven knowledge of why they're doing exceptions, and then things move forward. That's what I'd like to see. I would love to know whether Anders agrees, and also if you've ever seen that in practice.
Yeah, sure. I mean, for me, I think one of the main drivers of good, like, secure by default, it needs to be accompanied by a good, like, usability story or a user experience. Just take TLS for example. Like 10 years ago, it was still kind of rare to have encrypted traffic on like a normal blog or on any like regular website. It just wouldn't. It would just be like HTTP. Because if you were interested in having like encryption, you'd have to call one of these providers and ask them, like, and you have to talk to some sales person, and like it was just such a pain. So even if it was a good idea, like people couldn't be bothered. And of course, like the actual in terms of like technical what you need to do, it's not really changed in those years, but like how approachable that technology has become, like and how easy it is to just have a certificate issued these days compared to before. It just made all the difference. So now there's like, I don't know, but maybe I think it's only a few percent left of any traffic online which is no longer encrypted. So yeah, that's if you expect to have like secure defaults, you better make it easy for anyone to adopt those as well, or else it's like people are, even if you ship something and it's like it's secure by default, the first thing anyone is going to do is just turn every toggle off because it's just so complicated. So yeah, I think any security which is like too complex to grasp or to kind of work with is people are just going to disable that because it's just painful. So yeah, I wholeheartedly agree with like the secure by default philosophy, but we need to like any secure system which is unusable, it's not going to be either. It's not going to be secure or usable because people are just going to disable your security measures.
But I kind of get a slightly different twist to this answer. So Steve, do I understand correctly that you seem to both agree on the fact that we need to make security easy and we need to provide proper feedback to developers on why something needs to be secured in a certain way. But I have the feeling that Steve gives a bit of a different flavor, that basically as your code is moving from dev to production, you should be more and more restricted. Like, for example, if you're having your development code, you don't really care that you don't have HTTPS on localhost, right? That's perfectly okay to have. And then as you move into, for example, testing, there you should start to have maybe OPA in dry mode, in dry run. And then as you go to production, there really the policies are enforced. And then with proper feedback for the UI. Is this a good summary to give to what you answered, Steve?
That's a fair summary of what I said. Yeah, I think it's sometimes difficult to accomplish that. I mean, there are certain organizations I've worked with where, well, I've seen two sides of the coin. I've seen people saying, well, we need to keep dev wide open so we can make sure that from a feature and acceleration perspective, we make sure we can get the functionality out there. But then I've had other organizations, and I think I roughly agree with the other side of it, where if they have rules, if they're using OPA here, then they should have the same rules, even in dev, but just not enforced, just so that there's a intelligence feedback loop that's happening saying, it's all great, it all works, but they're never going to let you do this over here. So you need to start working on alternatives for this, and this. Or you need to put this in place, or you haven't got security context, or you haven't got all the other things that are in your YAML. So I like the idea of educating developers in a soft way earlier, but lets them move at the pace they need to move.
Anders, would you agree?
Yeah, no, for sure. And I think another one problem with having like one or kind of applying security to prod but not to dev, is that all these usability issues that we talked about before, you're not going to be really exposed to them if you don't see them in dev. But your customers, they're going to have to go through your like super painful multi-factor authentication process every time they log in. But your developers, they're not going to know because they're not really affected. So I think like a good way of actually making sure that your secure processes are refined and kind of improved on continuously is to actually like dog food that part of your whole stack as well. So if security is painful for your users, it should be painful for you as well, at least to some extent.
Yeah, it's actually off the back of that, I made it sound like security is pushing things onto developers, but it works in both ways, because if you try and put your security measures into dev, and then the devs actually find a way to bypass it there, even though it's just warnings or something, then you learn like, okay, that's not going to work. Security needs to learn from the developers as well. And it's a great opportunity for that to be a two-way street for education.
Mm. Yeah, thank you for this insight. We talked a lot about open policy agent and also about vulnerability scanners, and there are plenty of different open source projects to insert in your cloud native security pipeline. I have a question from the audience here. What should be the value that enterprise or commercial solution bring to this rich ecosystem? I'm not sure which order to take you, but you talk last, Steve, so maybe I take now Anders.
So what's the value of what?
Of enterprise. So we have many open source solutions in the security space from the Cloud Native Computing Foundation. What should be the value that enterprise and commercial solutions add on top of this?
All right. Yeah, I got you. I think like what open source does really well is kind of this distributed model where and it works very well with like the cloud native model, of course, where you have like 1,000 of instances running in all these different environments and all like these small components. But I think like a good space for the enterprise or enterprises is more like where you still need some kind of centralized management of what's really going on here. And of course, there's plenty of open source counter examples in that space as well. But I think that's like kind of like these API gateways or things where there's really like bigger components managing many small components. I think those are often kind of good fits for enterprise offerings. And even if there are many open source competitors, it's often kind of components where you want some level of support, because not only are they kind of big and complex, but they're often like pretty essential to anything that goes on in like a firewall or something like that. If it goes down, it's like everything goes down. And I think any component like that is a good candidate for building some business around.
Steve, what's your take on this question? Sorry.
Yeah, I'm going to add to that. So totally agree there. I think what was touched on, and I'd like to sort of add to, is it seems like a cliched answer, but scale. A lot of what is available in open source is great for smaller companies or teams to dip their toe in the security water and have something in place quickly and easily. But when you start talking about 10,000 developers, the centralized management that Anders alluded to is not just essential, but the ability to build upon that quickly and easily so that you can enable the solution that one team is using to spread with some level of uniformity. And big enterprise solutions, they thrive on bringing that together. The other aspect, I think there's three aspects, so I'll try and keep it short. The other one is taking the answers from one part of your pipeline and using them later. So if I'm plugging, taking a vulnerability scan, but then remembering the results of that when you scan the deployment so that you bring context to the vulnerabilities. and then remembering that as you run into runtime and knowing where your risks lie. So if you can do that, then you're bringing a new level of context and awareness to what was previously independent solutions from open source. And I think the last aspect I like about enterprise is that you benefit a lot from being a part of other large companies. And if you buy an enterprise solution, it doesn't matter what it is, then you benefit from the mistakes or the experience of other customers of the same enterprise solution. And those fixes can be crowdsourced long before you run into them. So you benefit from the incentivization of that organization to make it the experience pleasant for you.
Mm-hmm. Interesting answers. Thank you so much. So do I get it correctly? Basically, support for peace of mind, integration, and then also, well, code is one thing, and that you can download, it's open source, but then the experience that went into how to use that code and how to modify maybe for your own use case. Did I understand correctly? That's kind of what commercial offerings are best at adding value over open source solutions.
And I think, well, I mean, and as you scale, if there's a problem with a solution, the problem can scale with you. And enterprise solutions can make sure that doesn't happen for you.
Okay, and then we had also scaled to this mixture.
Right.
Yeah. A bit of a different kind of question. So we have two experts, and I assume that the audience must be very intimidated. Could you share something about like the worst security breach that you ever have seen yourself or experienced, or as much as you can share, right? Just a little bit to build confidence that, well, there are other shops that are worse than us. Let's start with you, Steve.
You can't name names if no one knows about it.
Definitely
so oh boy. I've seen multiple instances of the Tesla, the public Kubernetes dashboard. I have found in live presentations exposed WeaveScope examples where I could get access to running containers with a prompt. I did that in a live presentation once and then had to contact them immediately afterwards. And I can't say who that was. That was bad. These are all bad things, but they're all slight misconfigurations. I was once working with an organization, a large organization, who actually purchased our solutions and then put them into a cloud environment, but actually exposed the front end, not just to their internal, but to the world. Which is actually, that's worse than having a security problem. That's having a security problem, detailing it, and then telling the world by accident. So that was found very quickly, but it's interesting how just basic misconfigurations, particularly of cloud, since we talked about cloud security, can result in what on the edge of catastrophe because of that. I mean, it's amazing. I mean, we could talk about like known breaches, in my opinion, on those, but those are things that I have seen happen that never really went anywhere. So that's great.
Anders, could you share some stories of the worst security breaches or incidents that you have experienced or maybe you learned about?
Yeah, I think just as Steve said, I think the big ones I've experienced myself has mainly revolved around like people making mistakes or people don't really considering like the impact of what they were doing. And so, yeah, I think the biggest one I've been where I was there was probably somebody built a microservice to do like with authentication, and it was a simple like password credential microservice. So just send in your username and password and get to know if you're authenticated or not. And the way they would do that is like they would send in the username and password in the query string on a GET request, and of course. That would expose like these passwords to a whole lot of pretty much any system along the way, and so that's what happened. Hundreds or thousands of passwords and ended up in like if not public, then at least not not really well protected, like logging subsystems and so on. So those kind of incidents is probably the worst breaches I've come to know. But
it's funny that we run into these things and we're not trying. They just cross our paths as people who were working with organizations for like the past 5 years anyway, and they just we're not white hat researchers looking for them. So it must be an exciting world to be one of those people.
Yeah, time flies when you're having fun, and we're almost at the end of our allocated time slot. Steve, what are your main takeaway from today?
Well, I think I'm going to probably back Anders here. I like the idea of moving towards security as code. I think there's still ambiguity about what cloud native security means, just kind of based on some of the questions that we have. So there's obviously still work to be done, but I think I like the fact that we talk more about security now, and that we're having sessions like this is pretty good. And I think what used to be the bare minimum, even 5 years ago, is so much better than what we have today, thanks to organizations like CNCF propping up a lot of security tools in open source, and then extending upon those with just awareness that seems to come natural. Now, I'm not saying like we're in a great place. Education is still key, but based on the sort of questions we've come a long way.
Anders, what's your takeaway for the audience?
No, I certainly agree with what Steve said. I think it's essential, like in this kind of chaotic, or at least diverse environment, like it's essential to at least like codify your requirements. Don't just have like what Steve called tribal knowledge. You need to actually kind of write down, and you need preferably in some like declarative language, or some where you can actually where you can work with requirements and policy and whether it's like or network rules or whatever it is, like in a declarative way, where all of that is kind of under version control, and where you can work with best practices as code review. You can work with linters, unit tests. I think that's key for good security in this cloud native space.
And it's a very nice and positive message and feeling to take home, right? I mean, yes, we still have steps to take before we're perfect, but we have come a long way to improving. Steve, Anders, thank you so much for joining us today. Thank you also to the audience for all the really good questions, although Steve might have not appreciated their difficulty, but I think they were really good questions, and they were definitely very good to give some more substance to the discussion. With that, thank you very much, and have a pleasant afternoon or evening, depending on which time zone you're in.
Thanks,
Goodbye.
Cristian. Thanks, everybody.